Extensive ice reserves found on the Moon. Greetings everyone. Today's video focuses on recent research that has uncovered extensive evidence of water ice in permanently shadowed regions, PSRs, on the Moon, reaching beyond the South Pole to at least 77 degrees south latitude. This study, spearheaded by Dr. Timothy P. McClanahan from NASA, offers important maps for those planning lunar missions, highlighting that the coldest areas of PSRs contain the highest concentrations of ice. Various processes may lead to the accumulation of ice in these regions, and the research employed NASA's Lunar Exploration Neutron Detector to detect hydrogen concentrations, which are indicative of ice presence. Now, let's dive into our discussion. Previous research indicated the presence of ice in the larger permanently shadowed regions, PSRs, close to the lunar South Pole, specifically in the Cabeus, Haworth, Shoemaker and Faustini craters. In a recent study, Dr. Timothy P. McClanahan from NASA's Goddard Space Flight Center in Greenbelt, Maryland, who is the lead author of a paper published on October 2nd in the Planetary Science Journal, stated, "We find that there is widespread evidence of water ice within PSRs outside the South Pole, towards at least 77 degrees south latitude. The research also supports lunar mission planners by producing maps and pinpointing the surface features that indicate where ice may be present or absent, along with justifications for these findings. Our analysis and model indicate that the highest concentrations of ice are anticipated to be found close to the coldest areas of the permanently shadowed regions, PSRs, which are below 75 Kelvin, minus 198 degrees Celsius, or minus 325 degrees Fahrenheit, as well as near the base of the slopes that face toward the poles," McClanahan stated. "We are unable to precisely assess the amount of ice deposits in the PSRs or confirm if they are concealed beneath a dry regolith layer. Nevertheless, we anticipate that for every 1.2 square yards, 1 square meter of surface above these deposits, there should be approximately 5 additional quarts, 5 additional liters of ice within the top 3.3 feet, 1 meter of the surface in comparison to the surrounding regions," stated McClanahan. The research also indicated locations where smaller, fewer or lower concentration ice deposits are likely to be found, primarily in warmer areas that receive periodic illumination. Ice may become embedded in lunar regolith through impacts from comets and meteors, released as vapor from the interior of the Moon, or produced by chemical interactions between hydrogen from the solar wind and oxygen found in the regolith. Permanently shadowed regions, PSRs, are usually located in topographical depressions close to the Moon's poles. Due to the low angle of sunlight, these regions have remained in darkness for potentially billions of years, resulting in extremely cold temperatures. It is believed that ice molecules can be dislodged from the regolith by meteorite impacts, space radiation or sunlight, subsequently traveling across the lunar surface until they settle in a PSR, where they become trapped by the intense cold. The consistently frigid surfaces of PSRs can preserve ice molecules near the surface for possibly billions of years, allowing them to accumulate into deposits that could be rich enough for mining. Conversely, ice is thought to be rapidly lost from surfaces exposed to direct sunlight, which prevents significant accumulation. The team employed the Lunar Exploration Neutron Detector LENDI instrument from LRO to identify potential ice deposits by measuring moderate-energy epithermal neutrons. In particular, they utilized lens collimated sensor for epithermal neutrons, CSETN, which features a fixed field of view with a diameter of 18.6 miles, 30 kilometers. High-energy galactic cosmic rays, originating from significant deep space phenomena like supernovae, generate neutrons when they strike the lunar surface, disrupting regolith atoms and scattering subatomic particles known as neutrons. These neutrons can come from depths of up to approximately 3.3 feet, 1 meter, and travel through the regolith, colliding with other atoms. Some of these neutrons escape into space, where they are detectable by LEND. Given that hydrogen has a mass similar to that of a neutron, a collision with hydrogen results in a greater loss of energy for the neutron compared to interactions with most common regolith elements. Consequently, the presence of hydrogen in regolith leads to a corresponding decrease in the observed quantity of moderate energy neutrons. McClanahan stated, Our hypothesis was that if the hydrogen concentration is uniform across all PSRs, then CSETN should detect these concentrations in proportion to their areas. Therefore, a greater amount of hydrogen should be noted in the PSRs with larger areas. The model emerged from a theoretical analysis that illustrated how hydrogen-enhanced PSRs would be identified by CSETNs with a fixed area field of view. This correlation was established by examining neutron emissions from 502 PSRs, which varied in size from 1.5 square miles, 4 square kilometers, to 417 square miles, 1,079 square kilometers, compared to their adjacent areas with less hydrogen enhancement. As anticipated, the correlation was weak for the smaller PSRs, but it strengthened as the size of the PSRs increased. The LRO Project Science Team, along with NASA's Goddard Space Flight Center's Artificial Intelligence Working Group and NASA, grant number 80 GSFC 21M0002, sponsored the research. Utilizing NASA's LRO Diviner radiometer and Lunar Orbiter laser altimeter instruments, the study was carried out. The LEND instrument, which was created by the Russian space agency Roscosmos through its Space Research Institute, IKI, was integrated into the LRO spacecraft at NASA's Goddard Space Flight Center. NASA's Goddard Space Flight Center in Greenbelt, Maryland manages the LRO for the Science Mission Directorate at NASA headquarters in Washington. To support our channel's growth and ensure broader awareness, kindly hit the like, share and subscribe buttons. This will help us reach more individuals and disseminate valuable information. Thank you in advance.